let's start using these properties and getting comfortable with them. So our first task is to write some logs that are added and subtracted together as a single log. So it really simplifies the problem if we can put the logs together, if possible. So the first one says log base 5 of 4 plus log base 5 of 8 minus log base 5 of 2. Notice that all the bases are 5. That's why we can combine them into one log. Okay, so our first property says if we are adding two logs together, then we would multiply those results, right? So this is using property 1, log of a product, kind of in reverse. And you can use these properties in either direction. You can turn two logs into one, or you can take one and expand it into two. So here we are taking two logs or more into one. So we would have log base 5, and then we would do 4 times 8. Okay, so that part is log base 5 of 32. 4 times 8. We still have minus log base 5 of 2. So now let's say, well, if we are subtracting two logs with the same base, then we could turn that into one log by dividing the results. Okay, so m divided by n. So in this case, that would be log base 5 of 32 divided by 2. So log base 5 of 32 divided by 2 is 16. We can stop there. We won't necessarily need a decimal answer for any of these problems unless they specifically asked for that. Usually you want to just keep it as one simple log. All right, for number 2, we have 2 log base 5 of 4 minus 3 log base 5 of 2. Okay, if we have any powers out front, okay, this 2, we have to deal with that first, okay? So what we would say is that is log of a power rule. So change that to log base 5 of 4 squared, okay? That 2 out front is actually the power on the result, right? That's what that property says, and we're using it in reverse. We had log base a of m raised to the b power is the same as b times log base a of m. So we're going in the direction from like right to left on that power. All right, so that is equal to log base 5 of 4 times, or 4 squared, sorry, is 16. Okay, now let's do the same thing, I guess just in the same color, with this 3. So we still have minus, and then that's log base 5 of 2 raised to the 3rd power. So that 3 becomes the power. And then, of course, that is log base 5. 2 cubed is 2 times 2 times 2, so 8. Okay, now that we have the powers taken care of, now we're going to say, well, to combine it into one log, we are using the log of a quotient rule because we are subtracting. So that is equal to log base 5 of 16 over 8. Okay, you can use that as parentheses there, or not. Sometimes they like to show the parentheses. All right, so log base 5 of 16 over 8 is 2. Okay, let's do another. So in this case, we actually have a parentheses in the problem, and of course that means do that part first. Otherwise, we would just have to do it in order from left to right, right? But the parentheses is telling us to do that part first. So the part in the parentheses, I'm seeing log base 2 of y plus 3 log base 2 of z. Well, the 3 is going to become the exponent, right? And then we're adding these two logs together. So we could say, well, that would be log base 2 of y times z cubed. Okay, notice it's just the z that's cubed, not the y, because the y was over here and then we're just multiplying it by the z. Okay, so that's everything in parentheses. I did the two steps at the same time, and so don't get confused. I did the 3 here at the same time that I also did the log of a product. Okay, so I did the power rule and the product rule. All right, on this first one, I have 2 log base 2 of x, so I'm going to make the 2 become the exponent. So this is log base 2 of x squared. Okay, and notice that I still am subtracting that. So now that I have just 2 logs left, now I'm going to combine them, and I'm using log of a quotient because I'm subtracting. So as 1 log, that would be log base 2, and then on the top I would have x squared, and on the bottom I would have yz cubed. Okay, and then that's as far as I can go with my answer. All right, my next problem, I have log base 3 of 8 times log base 8 of 9. Well, be careful because it is already multiplied, right? So it's really not, it is 2 logs. So it's not the log of a product. That's not the rule, okay? And second thing to be careful of is they do not have the same base. So you wouldn't be combining them anyway, okay? So instead, I think the only thing you can do is say, well, I could use the change of base formula and see what happens, okay? So log base 3 of 8 could be written as log base 8 divided by, sorry, I said that wrong. Not log base 8, log of 8. The base is 10, right, when you change the base there. So I'm changing the base using number 5, the change of base formula, using this first rule. I'm changing the base here from this base to base 10. I'm doing the same thing in this problem. So now I have log of 8 divided by log of 3, right? And then I'm still going to multiply that by log base 8 of 9, but let's change that to log of 9 divided by log of 8. If you watched the calculator video, you did change of base formula already. And I know in that video I said you're going to put the base in the basement, right? So that's the rule for the change of base formula. You're going to change the base and you're going to put the base, log base 8, that goes in the basement. Okay, now take a look at what we've done. Well, now we have some simple algebra that we can perform. Log of 8 divided by log of 8 is 1 because anything divided by itself is 1, right? So now I have log of 9 divided by log of 3, okay? So I could keep going on this a little bit more because I'm noticing that 9 is 3 squared. I'm going to run out of room for this next problem, but that one doesn't take too much space, I don't think. All right, so log of 9 is 3 squared, and then this is log of 3, and then, oh, I love this, I get to use the log of a power property, so that's 2 log of 3, right? That's just that power, log of a power property, and that's divided by log 3. And then log 3 divided by log 3 is 1. So this is equal to 2. Okay? Now, at this point, when you had log 9 divided by log 3, I mean, if you typed that into your calculator, it would tell you it was 2. But it's kind of nice to see why that happens, of course. Okay. So last two, it is 3 raised to log base 3 of 8. Okay. This is a little complicated to understand, but we are taking the exponent and the log. These are going to undo each other. It's kind of like having a square of a square root or a square root and then you square it, right? They undo each other. This is a base 3 raised to the power, and the power is the log. So, and it's the same base, of course, it has to be the same base. This is equal to 8, okay? So it's just the base 3 and the log base 3 will undo each other because remember, logs and exponents are inverses of each other. Same way with number 6. E is the base, and guess what? With natural log, E is the base. So they undo each other, and this is equal to 10.